great. I will lead things off. I am Mike Madison, professor of law at the University of Pittsburgh School of Law and the host today. This is a presentation as part of the Future of Law in Technology and Governance series that is hosted and sponsored by the Center for Governance and Markets at the University of Pittsburgh and co-sponsored by something that I run at the law school called the Future Law Project. So super delighted to have as our speaker today, Sarah Lawsky. Sarah is a professor of law at the Northwestern Pritzker School of Law. We'll just say Northwestern Law, Northwestern University in Chicago, where she has been since 2015. And prior to that, she had faculty positions at the University of California, Irvine, previously taught full-time at the University of Virginia and George Washington University. So her talk today is, I'll let her give her own title and introduce it, but it's a super exciting talk that's precisely at the intersection of computing and computer science and legal systems and legal code. And so Sarah will talk for 25 minutes or so, and that will give us a full 30 minutes for Q&A. Sarah, I think you're gonna share some slides, so I'll hand it over to you.
Great, thank you so much, and thank you so much for inviting me. As I mentioned earlier, I kind of can't believe the group that I'm presenting here today. It's a small group, but with just absolute Thorne McCarty and Kevin Ashley, absolute luminaries in this field, and folks whose work I have been following and whose my work very explicitly builds on your work. So this is extremely exciting for me, and I'm going to try to keep this short so that I can leave a lot of space for your feedback. I also have a current student here. I have a former student. I have a tax law colleague, comp sci colleague. This is really great. So I'm incredibly excited, and I'll give my talk and try to keep it pretty short so we can really focus on the conversation. So people argue, and most recently this happened on Twitter. One of the people I'm working with posted about Catala, and someone jumped in to basically just insult the idea, to get into an argument over whether formalizing law by translating it into computer code is practical or effective or useful or desirable. But tax law has been formalized for years, and administering modern tax law would basically be impossible without this formalization. It's complex. Parts of it lend itself to being translated into formulas and algorithms, and tax authorities have done just this. Tax forms are formalizations. Tax authorities enforce tax law using computational versions of the law. Taxpayers pay for computer programs that prepare returns based on inputs from taxpayers. So the question is not whether to formalize tax law. The question is how best to formalize it. And the question of how to formalize it has two parts. First, so maybe an ambiguity in the word how. First, how the formalization would be accomplished, and second, the best version of the formalization itself. And for now, I'm going to take it as a given that formalization will, for the time being, have to be accomplished by humans formalizing the code, as opposed to computers analyzing large amounts of text to arrive at automated formalizations. Natural language processing, for example, has not been successful at translating tax law into computer code or any other formalization. So now I'm going to say something that you'll probably never heard anyone say before, and you won't ever hear anyone say again. This is the tax law right here. It's too short. It's too short. And it's also written it's strangely drafted. The way it's written isn't regular English, and it's inconsistently drafted. The ways that it's strange are different among different parts. There's not enough of this to do NLP. So maybe the answer is we need to write more tax. I don't think that's the answer. There may be some other answers than making more tax law. Okay, so for now, any formalization would have to be done in a way that we can do it, that people can do it. So I'm going to focus on the second question of the best version of the formalization itself and set aside that automation question. The most abstract level, tax law should be formalized in a way that maximizes transparency and government accountability and accuracy. I'm going to also take that as a baseline. So today what I'm going to focus on is a new programming language, Catala, which is created by a team of computer scientists, Denis Marigou, who's a graduate finishing up his graduate PhD at INRIA in France, Jonathan Protzenko, who's a researcher at Microsoft Labs, and two lawyers, myself, I'm a US tax lawyer, and Leanne Huttner, who's a French lawyer and also a graduate student in France. So Catala provides an approach to coding US tax law and French tax law, actually, but I'm going to focus on US tax law because I don't know that much about French law. That's sort of Leanne's place. Anyway, Catala provides an approach to coding US tax law that's tractable and functional. It provides a formalization that's more transparent and can keep the government more accountable than our current patchwork of forms and worksheets and secret programs. So I'm going to describe a particular programming language, but 3 characteristics of this language, 3 ways that we're approaching this project can generalize to other programming languages that formalize the law. So first, Catala is a domain-specific programming language. It is specifically designed for formalizing tax law. Second, computer code is created in Catala using an approach that is very well known in computer science. None of this is like new, it's just, which is pair programming. And in this implementation, this takes advantage of both the knowledge of lawyers and computer coders. And third, we use literate programming to create computer code that is more easily readable by humans and that communicates to humans the decisions behind the coding, among other things. So let me be totally clear. Formalizing tax law in this way won't eliminate ambiguities in tax law. It's not going to allow for predictions of how cases will come out. It's not machine learning. It's not artificial intelligence. All we're trying to do is do the boring parts better. But doing the boring parts better, formalizing tax law more completely and transparently, could have significant benefits, and as I'll describe, maybe significant risks as well. So first, I'm going to briefly describe the current state of automating the application of US tax law, and then I'll explain the approach of the Catala programming language to coding tax law and how this helps support accountability. And then I'm going to consider maybe some benefits of doing this and also some potential concerns about coding tax law. So first, let me just talk briefly about the current state of automating the application of US tax law. So parts of tax law are already computationally accessible. Tax forms and worksheets create algorithms that allow taxpayers to comply with portions of tax law. The vast majority of US taxpayers prepare their returns using computer programs that are created by and that profit companies in the private sector, but are based on these government created forms. And the US government provides some automated guidance as well. Now, look, there are these tax forms, these programs that exist, and many people say to me when I describe to them this project, that tax law is already formalized in a way that closely tracks the underlying law. This is almost certainly not correct. TurboTax and other similar programs are not representing the tax law in a way that faithfully represents the law itself. The tax preparation programs are meant to prepare tax forms. And so what they're encoding is the tax forms and the worksheets that are created by the government. Now, the forms and the worksheets are accurate for the most part, but they're very far abstracted from the tax law. And I have an example of this in my paper. There's tons of examples. They don't track the underlying law, and untangling how they relate to the law can be incredibly difficult. So revealing formalizations increases transparency and government accountability, but that's not enough because the formalization itself can be obscure. So if you reveal the formalization and the formalization is obscure, then we don't really have the transparency and accountability. Additionally, I'll set that aside. Occasionally you'll have the forms actually resolving like a structural ambiguity. But even forms and worksheets that don't resolve ambiguities can obscure the law. I just think there's a fundamental tension between writing the most efficient algorithm, writing a form that requires the fewest possible steps, and writing a form that actually represents the structure of the language of the law. It's just a fundamental tension. And the same issues arise in the context of automated tax guidance, which the US government regularly provides to taxpayers. So for example, the IRS provides an interactive tax assistant. It's called ITA, I don't know. I've heard this, so I'll say ITA. I've also heard someone said IDA. I don't think it's IDA, ITA. It's an online tool that walks taxpayers through various questions and then provides them with tax guidance based on their answers to these questions. The questions are like, do I need to file a tax return this year? Or things like that. So underlying the ITA is in some sense a formalization of the law. It takes inputs from the taxpayer, aligns those inputs with underlying tax rules in some sense, and then tells the taxpayer how the law applies to them. But honestly, as has been shown pretty persuasively in a paper in an ongoing project by Josh Blank and Lawsky to tax law professors in the United States, is this guidance is often either incorrect or obscures the contested decisions that the government made to arrive at these answers. So the ITA's simplified formalization of law thus not only provides taxpayers with frequently incorrect guidance, it also obscures the actual law and reduces government accountability. Okay, so the US government already formalizes tax law, but existing formalizations don't track the underlying law. They're oversimplified and incorrect, and they obscure the judgments and decisions that the formalizers have made, reducing government accountability. But tax law can be formalized and translated into computer code in a way that is tractable, accountable, functional, and increases government accountability. And that's the motivator behind this programming language that we're creating, Catala. It's a programming language just specifically for this purpose. So I said I was going to talk about these three aspects. It's domain specific, we use pair programming, and use literate programming. Let me talk about each of these. So Catala is domain specific, which is to say it's a programming language designed for a particular purpose or application, as opposed to like a general purpose programming language like Python or something like that. So it's domain specific in a lot of ways, but I'm going to focus on just one in this talk, which is the underlying structure of Catala. Catala is structured using default logic. It's a non-standard logic that represents the underlying structure of the US tax code much more accurately than does standard logic. And I need to just say here that Thorin McCarty knows this perfectly well, and he's been saying this for a long, long time. This is not an insight that is new to me. This is what I wrote my dissertation about, building on his work and others' work as well. So periodically, we can go back and see people recognize that there is this structure, this defeasibility within the law itself. So we use default logic, so let me talk a little bit about this. So I'm just going to share my screen here real quick. All right. So let's look at this general rules followed by exceptions. So the general rule, for example, the general rule is that section 61A11 says income from discharge of indebtedness is included in gross income. Then there's an exception to the general rule, 108A1B, that says income from discharge of indebtedness is not included if the discharge occurs when the taxpayer is insolvent. And then there's an exception to the exception, which is 108A3, which says that the insolvency exception applies only to the extent that the taxpayer is insolvent. That is, to the extent that the taxpayer's liabilities exceeds the taxpayer's assets right before the debt is discharged. Okay, so we have a general rule followed by exceptions. So because the statute is structured as a general rule followed by exceptions, it's easiest to represent the statute using a logic itself that is structured as a logic of exceptions. And default logic is one instantiation of this. So the basic idea of the default logic we're using, it's a prioritized default logic, and that you have rules of higher priority that override rules of lower priority. And in default logic, you can arrive at a conclusion that is entirely logically supported, and then provided with more information, you reject that conclusion that you had previously. So this is in contrast to standard logic, where information can only be added, and then it can't be overwritten once you've proven it in the system. So standard logic is monotonic. The set of what's proven can only grow. I add something, I can never take it out. Default logic is non-monotonic, because sometimes I can prove something with one set of information, and then I have to backtrack when I get more information. So this is how people reason in everyday life, by accepting and acting on conclusions, but being open to rejecting those conclusions if you get more information. So the canonical example that you'll see around this is of Tweety the bird. And so if someone tells you that Tweety is a bird and says, can Tweety fly? And you have to say yes or no, probably you'll say yes. But then they say, I'm going to give you more information. Tweety is a penguin. You're like, oh, no, then. There are a surprisingly wide range of penguin default logic cartoons you can find on the internet that I will, and a fairly contested extension of this in which the penguin has a rocket pack, where some people feel that this is an exception to the exception and other feels that simply proves that the penguin can't fly. Why else would he need a rocket pack? Okay, but we're going to set that aside. That is not important to this talk. So default logic is thus sometimes called the logic of everyday reasoning. Now, I want to be clear here that which logic to pick is a pragmatic choice. I am not saying that the only way to represent the tax law is to use default logic. Default logic and standard logic can be used to represent the same law, both equally accurately. So let's take a look. Okay, so let's take a look at what we just looked at here. So we can basically just write down the three rules that we just had in default logic. So first, we're going to have the general rule that if there's a certain amount of income from discharge of indebtedness, then it has to include it in income. And then we're going to have an exception, which is that we don't have to include it if the taxpayer is insolvent. And then there's going to be an exception to the exception, which is that the insolvency exception only applies to the extent of insolvency. These track the relevant sections of the code. Then we can rank the rules. The most specific rule controls over the second most specific rule, which controls over the general rule. It's actually amazing how much we believe this, so much so that like nobody has to say that, like, this is how statutes are written, but you don't have to give people the extra information. Oh, by the way, the general controls over the specific. Everybody knows this. Okay, so the same set of rules could be written in a single statement in standard logic. No problem. There it is. No problem. And there's a formal result that sort of the end output, and this is a comment, actually very helpful comment from Thorne McCarty. That was like, Twitter is horrible and also great, which is that the process isn't the same, but so there's a formal result that you can represent anything in standard logic. The default logic and standard logic have the same representation. It doesn't mean they're the same logics, just that the end of it, after the sort of dynamic part is done, is the same thing. So in terms of outputs given inputs, these two representations are the same. But the representation in default logic, I would argue, has several advantages because it tracks the structure of the statute itself. So most critically, the version in standard logic is incomplete and wrong as it is drafted. So as drafted, it captures only one of many exceptions outlined in section 108. Discharge of indebtedness can also be excluded, for example, if the discharge occurs in a Title 11 case, or it's qualified farm indebtedness, or doesn't happen, on and on. So to write the statement correctly, you'd have to include all of the exceptions to the inclusion of cancellation of indebtedness income. And so it's not right as it's currently drafted, because it says if the taxpayer is insolvent, then it has to be included. So it's monotonic. So once something is added, you can't retract the knowledge. So to formalize in standard logic, you have to know all the relevant exceptions. The default logic formalization is incomplete, but not wrong. Other exceptions could be added that would override the initial rule, but you don't have to have a disclaimer, because built into the idea of default logic is the idea that future rules, future information could provide different outcomes. Additionally, and relatedly, translating the statute into default logic is easier than translating the statute into standard logic, because the underlying logic tracks the statute. So the default logic translation can just follow the statute itself. And just as getting the law into the default logic formalization is easier, getting the law out of the default logic formalization is easier. It's easier to see how the default logic formalization matches the statute. And so the default logic formalization increases transparency and accountability of the drafter in the computer code. Finally, if the statute changes, it will be easier to change the default logic formalization. So you remove an exception in standard logic, you have to untangle a statement in which every part depended on every other part. But because default logic tracks the statute so closely, and because default logic allows for exceptions that override more general rules, formalizing in default logic allows separate sections and subsections of the code to stay separate. So the drafting is sort of more modular than formalization in standard logic. You can swap the new law in and out more easily. Sometimes the word you'll hear here is brittle. The standard logic of formalization is very brittle formalization, whereas the default logic just lets you move pieces around more easily. The second important part of our approach to Catala is the approach to coding known as pair programming. So turning legal code into computer code by hand requires expertise in both law and coding. And one approach would be to train individuals in both skills. So you can have law schools that have classes in coding, or train coders in tax law. The concern, of course, is that it's really easy to train someone to be a bad coder, but being a good coder takes a lot of time and experience. And it's not an easy matter to read tax statutes well, with an understanding not just of the language of the statute itself, but of how that language is meant to interact with the rest of the statute and regulations. Even if one person did have sufficient expertise in both tax law and coding, the task of formalizing statutes is sufficiently subtle that it should not be turned over to only one person. A committee of experts, for example, works together to create the forms at the IRS. So pair programming is a better approach to coding the code. Usually this refers to two programmers working together, but pair programming here, I don't mean two coders with similar skills, but a coder and a lawyer, people with radically different areas of expertise. And that way you can get the law coded without having a single person who has to be an expert in both. So maybe the lawyer can know a little bit about the coding, and maybe so they can read the code, and the programmer could do a little reading about tax law, but you don't have to be fully trained. So finally, the code includes not only the language that the computer interprets to determine what to do, but also extensive comments that are aimed at the human reader of the code. And this is the theory of literate programming, which is sort of first put forward by Donald Knuth. And the idea here is a program doesn't communicate only to a computer, say to what the computer should do, but also communicates to the people reading the program, what the program wants the computer to do. It's widely popular within math and science programming. It allows computational analysis in those areas to be more easily explained, shared, and replicated. And so Catala code doesn't just include the functional code, it actually also includes the relevant statutory and regulatory language in a comment for the humans, and also explains the coding team's decisions, including in some cases extra statutory legal support. And also the comments can make explicit the ambiguities the team perceived and whether, how, and why the team chose to resolve the ambiguities as they did. All right, so, and I'm happy to expand on any of this during the question and answer period. So let me just talk a little bit about what things look like if the code gets coded. So let's say, okay, this is a way to do it. What comes next? So Catala, let's say it makes the task of translating tax law into computer code tractable. So probably we're not going to get the whole thing translated, but you could translate portions, and even translating a small subset of the code and regs could be highly useful. Partnership tax code and regs are almost entirely self-contained. Compliance rules, pretty self-contained. So coding significant and relevant portions of the code might be imminent. Now, to be clear, Catala doesn't create any of the possibilities of what I'm about to describe, but having Catala, which is designed to code the tax law transparently and efficiently, makes computational access to the tax law more possible, and with everything that would flow from that access. And so I'm trying to think about what would flow from that. Let's say we really did this, what might come next? Well, for one thing, if we formalize the law using Catala in a way that is faithful to the underlying structure of the law and open about the ambiguities that would remain, it's going to obviate the need for other formalizations. Instead of creating separate formalizations for forms, the ITA and so forth, the IRS could draw on the underlying formalization of the law itself. This could allow the IRS to provide more accurate guidance to taxpayers who can't afford to hire a tax professional. They might be spared from having to create forms, which is a time-consuming process that for some forms is an annual task. It might make it easier for the government to provide online tax preparation services as opposed to outsourcing those services to for-profit entities. We can talk more about that. I think people on this call may well know about this sort of amazing, and I don't mean that in a good way, situation with the privatization of tax preparation in the United States. I will tell you one of the things about working with the French lawyers and coders, when I explained to them how tax filing works in the United States, they thought I was making it up. They just were like, this is definitely not how it works. I was like, I am telling you the truth. This is definitely how it works. It's pretty shocking. So maybe this could help get rid of that. That's the good side of things. However, coding tax law could also provide a path to tax avoidance. And this would make it really critical that the government, as well as private taxpayers, would have access to computationally tractable law. And in particular, coding tax law could make it much easier to create certain types of tax shelters. So some tax shelters achieve their results by giving legislatively unintended meaning to words, and some tax shelters achieve their results simply through falsehoods, inflating the amount of a charitable contribution. So those are very boring. Lying is very boring. And sometimes in class, my students say, well, what if you just tell the government that you didn't have income? I'm like, I don't care. I mean, lie to them. This is not interesting at all. However, some shelters work by chaining together seemingly disparate rules to create a tax avoidance situation. So humans are good at expanding the definition of terms. Humans are good at lying, but computers are way better than humans at looking at huge numbers of permutations of increasingly complex rules and fact patterns and finding the combination of rules, structures, and facts that minimizes the amount of tax owed. So in other words, successful tax shelters can be created not just by exploiting ambiguity in a term or by lying about valuation or another fact, but by chaining apparently unrelated provisions of the tax code to create an unintended tax savings opportunity while still following the letter of the law closely enough that a court will uphold the structure. That's the key part. And these gaps in taxation are created by the complexity of the code itself. So there's a Sixth Circuit case, Summa Holdings, that upheld one of these structures. And what the court said was the taxpayers, quote, complied in full with the printed and accessible words of the tax law. The taxpayer, to its good fortune, had the time and patience and money to understand how a complex set of tax provisions could lower its taxes. Now, if the corpus of tax law is made available to computation, you're not going to need time, you're not going to need patience, you're not going to need money to determine how a complex set of tax provisions can lower your taxes. And a computer might be able to sort through various permutations of law, regulations, facts to find opportunities for chaining these provisions together. If you develop a program like this, the marginal cost of developing a tax shelter would drop to zero, the marginal cost, once you have this in place. And the IRS shuts down one shelter, another shelter will be marketed to take its place. And even if in theory anyone could generate a tax shelter, because of the way our tax law works, tax shelters in fact benefit only wealthy people. There aren't really tax shelters for people who aren't wealthy. Generating tax shelters from computationally accessible tax law has already been shown to be possible. This was a group out of MIT that did this, used this to, they formalized a portion of partnership tax regs and used it to generate a tax shelter. The tax shelter they generated was actually one that we already knew, but like the computer found it, which was kind of terrifying. So Catala does not create this possibility, but Catala does make it easier to make the tax law computationally accessible, because it allows the law to be coded in a way that tracks the law itself. And once you have the law to be computationally accessible, tax shelters will be easier to generate. So one way to address this is for the IRS to have its own computationally accessible tax law and use it to create, flag, and ban tax shelters. Defining tax shelters is notoriously difficult, but with computationally accessible tax law, instead of attempting to characterize or theorize the type of transaction not permitted, the IRS could essentially brute force the problem with its own program and then just say, you can't do this stuff, here's the list. And allowing private individuals or industry to create computationally accessible tax law without the governments also having such a corpus would be disastrous, because then you have wealthy taxpayers potentially identifying and implementing tax shelters at little or no marginal cost. Ideally, the computer code of the tax law and the programs necessary to use this code wouldn't be limited to the government. In fact, it would be open source and accessible to all. So the openness would create transparency and accountability, which is great, but open source tax code would also give individuals and nonprofits the ability to help out, essentially to find bad stuff and flag it for the government. Tax law is already formalized. It's in the patchwork of inaccessible, obscure, and sometimes inaccurate formalizations, thus reducing both the general usefulness of the formalizations and government accountability. This new programming language, Catala, is designed to formalize tax law accurately and accountably, could have benefits for tax law administration and for government accountability, but formalizing tax law could also make tax shelters easier to create, and private individuals and businesses therefore have significant incentive to use Catala or another domain-specific language to codify tax law for their own benefit. So whether it's with Catala or something else, I think it's critical that the government acts. The government needs to get ahead of this, create a computationally accessible version of tax law, or someone else is going to come in and do it for them. So I want to close by just sort of mentioning that Catala is part of, I think, a larger growing field of programming languages for the law. And we're gonna, there's actually a workshop that Jonathan and Denny and I organized that's gonna be part of the, not part of, but like adjacent to the big programming POPL in January. It's a one-day workshop just about programming languages in the law. And I couldn't believe, it was one day, I couldn't believe how many proposals we got. So I think like a lot of people are working on this and focusing on this as, I think thinking of this as one area, as like a specific programming languages question. It's ultimately going to be beneficial, whether it's this programming language or other programming languages. People are thinking about this question, developing new tools, and some of the things I outlined at the end of the talk, may be imminent, should be things to keep in mind. So I want to end there. I don't want to take up too much time because I'd love to hear comments, questions, thoughts. Lots of things here I could expand on if people want me to. So, yeah.
Awesome. Thank you. Thank you, Sarah. So we've got a good amount of time for questions and follow up. Jason, let's start with you.
Hi, Michael. Sorry, I was actually just trying to click the applause reaction for Sarah's talk. I didn't mean to put my hand up.
Oh, okay. That's fine. More applause.
Philip has a question, I think.
Oh, Phil, there you go. I'm looking for the little icon, but you're just actually doing the human thing.
Yeah. Thank you for this, and I'm super excited about the project. I'm a big supporter of use flagging.
Bill, you're cutting in and out.
Am I? Okay, sorry. Let me, is that better? Am I
Yes.
cutting in and out now? Is that better?
I think
Wow,
that's better.
that's
Okay.
impressive.
So, when I worked there, sometimes Congress would pass new laws and we would have to adjust the form. You'd have to quickly process what they've done, try to integrate it with what has come before, and figure out what it means. And nobody really knows once that comes in. So the people who are understanding the law don't know what it means. And in fact, you don't want to take positions on certain things yet, because you want to get a lot more information before you make that decision. So just thinking about that aspect of it, which is that I don't have the right as an individual to make that call. And I should not make that call. In effect, the programming would potentially have the effect of, by default, making that decision. And I'm wondering about the thoughts of that aspect of its impact in a democratic order and democratic process.
So I don't think it has to do that. I think that when there are ambiguities, so what I always think of this as is a path from sort of like difficult question to difficult question. You can have a lot of difficult questions, but if the traveling from one to the other is sufficiently complex, code helps. So if you can't answer a question about what a term means or how terms relate to each other or anything like that, it's okay, leave it ambiguous in the code. Because even getting 80% of what's going on in there and just saying with these, I don't know, I can't code this, I don't know, that is still getting us somewhere. So in law, I think we tend to focus a lot on the edge cases. That's what we make our money from as lawyers, right? That's what we argue about in court. And I think when I say that I'm talking about the boring stuff, I can't emphasize that enough. I am talking about the boring stuff. And these edge cases, the hard questions, absolutely can be reserved when this stuff is coded. If we get 80% of the interactions in there, that's getting us very far. And we see that on the forums all the time. That we see on the forms, put the amount of income in here. What's the amount of income? I don't know. The form doesn't know. We can do that in computer code too. We can just say the thing that put a number in here. How do they get that number? It's not my problem. But once the number gets in there, we know that it interacts in this way and that way, and then so I think that I'm not worried about that part of it, because if we don't know, you just don't code it. You just say I don't know. Or you say, the other thing you could say is, here's 3 possible things this could mean. I don't know which one it means. Here's code for each of them. Taxpayer, whichever you think is the right one, you do that one, right? So you could also do that, right? I mean, you really could. It's like if the ambiguity is actually between 2 or 3 things, put it in there, put it in the code, let the taxpayer pick,
And that's effectively what the have often does. You
yes,
have a
exactly.
safe harbor if you do this. We
and
don't know
just
what the
make
heck's going to happen.
Make it explicit. So I just think do the easy stuff in some sense and let the hard stuff be reserved. And we still get a lot of we still make a lot of process. Okay, so the question of whether it's possible to automatically code into Catala, I don't know. I really do. I mentioned this a little bit earlier. I'm a little skeptical but maybe, I don't know. I don't think that automation would undermine objectives. Maybe you could get an automation to do a first cut and then have someone come in and clean it up. I just don't have any indication right now that, given the NLP stuff and other similar related things, that there's much progress in being able to do this. But I'm not very much not an expert. I'm very much not an expert in that area. So I don't know. I'm not an NLP expert. I think Kevin, did you have a question?
Yes. So you've talked a bit about the terms and the ambiguity due to the terms. Another old-time AI and law person, Layman Allen, used to focus on the logical ambiguity of the statutes, and the fact that in natural language text, we don't use parentheses to indicate the scopes of the logical connectors. That was one source, and I'm interested to know how you deal with that. But another source that Lehman Allen spoke of was the fact that these exceptions are all over the place in the code. It's not just within one provision, but there are other provisions as well. And so he developed that normalization approach to coming up with a pathway. You mentioned paths. Well, this was a real path through not only a given provision, but relating different provisions to one another. And that's the second part of my question. My sense is that the priorities bury that in a way. You sort of don't know how the priorities are going to resolve themselves, except at runtime, for a particular problem. Whereas with the normalization approach, you sort of created a pathway that related the different provisions as well as internally dealt with ambiguities.
So I think that you essentially have to do the normalization approach to the coding. I think that you kind of can't wait. You actually have to do that. And one question that we really spent a lot of time thinking about, and I think we think the answer is no, but we're looking around, the answer, which is, could you ever have a situation where you actually couldn't prioritize the rules, or where you would have two different possible priorities? That's just a factual question about the code. We haven't looked at every single thing, but I think that those pathways are essentially what you have to do to order I think that has to be part of the formalization. You've got to do it in advance to do this appropriately. It's hard. Mm-hmm. With respect to scope ambiguity, I'm super interested in scope ambiguity. I think it's I've actually written a paper about this because I'm so interested in this. I think there's scope ambiguity. There's also ambiguity about ordering for certain types of questions. So I actually found this one ambiguity in a new statute a couple years ago, where I think it's actually not obvious, which order you should do things in, and the form picks a particular order. And I actually think the form is resolving an actual open question of law implicit in the form, but you would never know that from the form itself. And so I think drawing out those ambiguities and making it explicit in the comments that there is an ambiguity and you have resolved it in a certain way, or there is an ambiguity and here are two possible ways it could be resolved. That's actually a huge part of what I want this to do, because right now they're making forms that resolve these ambiguities and they never even tell people that the ambiguities are there. So acknowledging those types of ambiguities is how I would address them, and how I've talked to the team about addressing them, and just being really explicit about what's going on there, because I think that's critical. I'm not super interested, I'll confess, in term ambiguity. I'm whatever, but I'm super interested in scope and logical ordering ambiguity, and I think that there is more of that in the code than we know. And so I think bringing that to the surface is part of the project here, and making it explicit. Thorn.
So let's go to Thorn next, and I see Jason has a couple of questions in the comment.
Thorn.
Okay, can you hear me?
Yes.
Can you hear me? Yes.
Yes.
Okay, so let me say a couple of things about your technical points about default logic. So you're using default logic, and since I've read your paper on that, you're specifically referring to Ray Ryder's default logic. Is that correct? Yes. Okay. So now Ray's system and most of the systems of default logic that were built at that time were concerned about what you do when these default rules all conflict. That you have to pick one of the extensions or something like that, or you have to say you're going to be cautious and require a conclusion to be true in all extensions, or non-cautious and accepted, so on. But I think, and I've written this some time ago, that if your draft of a statute turns out to have multiple extensions, it's incorrectly drafted, it's incoherent. And so now you can see this quite clearly I prefer, for the default rules, I prefer simple negationist failure in logic programming. It's very simple to understand. Well, it's not simple to understand, it's complex also, but there's a very good theory. And one of the distinctions that's very clear when you look at logic programming with negationist failure is you can distinguish between what are called stratified negation as failure, and unstratified. So the classic example of an unstratified rule is something like P if not Q, Q if not P, okay? So that's an unstratified rule, and you have two extensions in any system that tries to handle those rules. And I think if your statute gives you that result, the statute is just incoherent and badly drafted. So I would say, but there's a therapeutic application of that idea here, which is, let's suppose that you use negation as failure. Then it's very easy to test, even if the statute is very complex, whether your rules are stratified or not. And if they're unstratified, then rather than taking one of the very complex semantics for picking one of the extensions, or even computing all of the extensions or whatever, and there's a huge choice of different formalisms which give you different answers. Rather than choosing one of those, you should simply say, no, I've got to redraft the statute at this point. I've got to make sure I have no unstratified rules in my system. And so by the way, I agree completely with everything you say about the way we should be using some kind of default logic for pragmatic reasons in drafting the code for the code. I'm just saying go a little bit further and try to enforce this coherence, let's call it a coherence criteria, which I think is very important.
Thank you so much for this comment. It's super helpful. So this actually is a lead in a little bit to the next part that we're working on right now, which was we're essentially working on a proof engine for this to look for exactly what you're talking about. So this is exactly what we're checking for. And this is exactly what we're going to plan to do. Now, I think you've actually just proposed a much more efficient way to do this so that's a great point. But the more generally, this idea of looking for the incoherence, the theorem prover is basically going to be doing that with what we're coding. And so one of the things it's going to be doing is looking for incoherence, and then exactly as you say, just throw it out. The other thing it's going to be doing is basically looking for not incoherence, but the theorem prover will also be able to essentially look for tax shelters. So, but the main thing it does right now is look for this incoherence. And actually we were able to get it to, this is a very small result and we really have a lot more work to do, but we were able to get to find one in the French benefits code, which is kind of amazing. The actual French, the French family benefits code, it found an incoherence. Like actually it was there, like, and it was actually there and was right. But there's a ton more work to do on the theorem prover on that side. But this I think is like absolutely right. And thank you so much for this comment about the underlying approach. That just seems, it's so helpful. I'm going to pass it along to my team.
Hey. Thanks. Okay, Jason, you've been patient and thanks for joining us today.
Oh, no, absolutely. My pleasure. I've been so excited about this since I heard it was happening. I'll just give a different perspective. And I think actually Thorne and I have had a conversation similar to this on Twitter about this. So I'll probably be boring him somewhat. But I have a bit of a different perspective in terms of whether it's good enough to say the law is badly drafted and that's why I can't encode it. To my mind, a lot of the benefits that Professor Lawsky is describing, those benefits depend on being able to do something with the encoding that you have. And if the way that you're encoding the legislation just breaks down in the presence of certain kinds of bad drafting practices, and you end up with software that won't do anything because, for example, it has an internal contradiction and so nothing is true. That kind of technology is really only useful for perfect statutes, for generating applications that will like fill in forms and things like that. The software that can only say correct things, can only say internally consistent things, is not going to be able to describe most laws.
Yeah, so I think
And
I disagree with you here about whether it's helpful to be able to say partial things. It's clearly helpful in tax law, because I know this because there is a ton of formalizations running around saying partial things about tax law.
oh no, you and I are on the same side of that argument.
Yeah.
What-
So, I mean, I still think, would it be better if it were? So first of all, I don't know. I think, although I love finding actual mistakes, it's very uncommon. Like mostly they're not actually making mistakes. And if they are making mistakes, they come back and fix them. I think the bigger problem is ambiguities, where you're resolving ambiguities one way or another. And as Philip pointed out, you may not be picking the right one. And so then, my saying, oh, well, you just do it two different ways and you have to pick one. I think this gets at your point too. Like, well, that's not really doing much, is it? Like, that's kind of like making these two different paths.
Well, I think it's a different thing. Like I'm speaking in the scope of choosing which technologies we use to do these kinds of encodings. I don't like when the technology breaks down in the presence of bad legal drafting. Because if the technology stops working in the presence of bad legal drafting, there is a vast realm of legal technology we're not going to be able to use it on.
Stops working. What do you mean by stops working?
Well, I mean, if for example, what Thorne was talking about there is if you have non-stratified negation inside your legislation, you try to represent that inside your logic program is not going to work properly. And what Thorne proposes as a solution to that problem is redraft the legislation. Well, most people can't redraft the legislation, and most people need to calculate something in the meantime.
Okay, so this is a good point, and this is something that I kind of love about tax law that's different than other types of law, which is other types of law, your client can have a question, and you'll be like, I don't know, man, like, let's just see how it plays out. Like, hopefully this just kind of won't come up. You probably never end up in court. It does not work that way for your client in tax law, because your client is like, tell me how many dollars to pay at the end of the year. Like, how many dollars do I pay? And so all of these questions that you can push off, it's as if every year, the fact that every year, I mean, really more frequently than every year, but we get to file a return every year. We are constantly making choices about how to comply with tax law in a way that we just aren't constantly making choices in other areas. Or we're making the choices, but we never have to be held to account. I mean, the chance you're going to get. But for tax law and your clients, you can't say to your client, I don't know. We'll figure it out later. They're like, yes or no. Does it go in the income or not? And so you have to make these decisions every year. And so this is why when in the situation, which I think is vanishingly rare in US tax law, and I think it is because I'm looking for it, I'd be so thrilled to find it. In the situation where you just actually had something that did not work, what would happen, and I think Philip can back me up maybe on this, is the IRS would solve it for you. They actually would just come out and be like, eeks are bad. We know you have to file your return by the end of the year. If you take this approach, we promise not to come after you for doing this. So they're not saying this is the law, but when the enforcer says, it's okay with us if you do this, then that's what you do. And so one of the great things about, sorry, Philip, go ahead.
Yeah, all the time. You're always in that position in the tax law because people are having to make decisions every year. And so the IRS will come out and say, listen, we know this is confusing. If you take this position, we won't do anything.
And so they're resolving these questions for us constantly because people have to pay tax. And so tax might be special here, where it's not going to be a situation where we're just like, I don't know, we're stuck. We better wait till the court resolves it. We're getting the answers constantly because people have to file their returns. So I do think tax law in the United States is uniquely well suited for this. And part of the reason is because of this extremely fast feedback we get from the agency that administers the law, because we have to have answers because the clients have to know.
So then what we would need to be encoding is not just the tax law, but the tax law and the guidance.
Absolutely. And so that's what that's when I say the code, I'm really and I mentioned this when I talk about, sorry, go ahead, Philip.
I was going to say, look at Sarah's books behind you. There's the 2 code in red, and then the rest is purple. That's all the guidance, and the other is the
right. And I would go even
key
further.
Part of it.
Right. I would go even further. I'd put revenue rulings in there. This is what I was saying about the illiterate programming stuff. We want to have in that saying, here's how we're doing this. And we made this decision based on what the law says. And this line here doesn't encode the reg, the code. It encodes the reg. And this doesn't encode the reg. This includes revenue ruling 97 - whatever. And I think that's the only way to go forward with tax, because you cannot pretend that this guidance isn't isn't giving us information about what to do. The other thing I like about this, which I don't talk about in this paper, but it's something else I like about using a default logic approach, is that here are two different questions. I am filing my tax return. What should I do? What is the law? And I am going to court. What is the law? If I am filing my tax return, any tax lawyer would do this. If I'm filing my tax return, I'm probably following a revenue ruling. I'm probably following something like, if I'm going to court, and so I have to like order my rules, and I would say this rule in the revenue ruling is more important than this rule here is more. If I'm going to court and I tell the court that something's in a revenue ruling, they're going to yell at me. And you can see this in these court cases where they're like, why are you telling me about a revenue ruling? A revenue ruling means nothing to me. I am a court. And so actually the ability to reorder the rules and say, for the purpose, if the question is, how should I file my return? The rules are ordered like this. If the question is, what should I do for a court? The rules are ordered like this. That's really important because the different sources of tax law have significantly different value depending on what question you're trying to answer. So this is another reason why I think I like the explicit ordering of rules here, because for tax, it's really different. So yes, and I should make this crystal clear. I am not really just talking about this. I'm talking about all this and a whole bunch of other stuff. There's an example in the paper that I give of you're supposed to allocate something pro rata. Well, how am I supposed to allocate it pro rata? By the minute? By the day? What are you talking about? Like, should I take into account that it was a leap year? Help. And the regs say, you can do it by month or you can do it by day. There's 12 months in a year. There's 360 days in a year. It's okay. I mean, just making stuff up, because how else can you implement it? The regs tell us, so we got to put in the code and we got to put in the other sources of law too. Yeah, Michael, sorry.
I'm raising my own hand because we're going to run out of time, and I wanted to get a thought in on this really interesting piece of the conversation. I have no access to the computational piece of it, but this piece I can. So there's partly this is just an observation, which is this part of the conversation gets at a very interesting, very slippery sort of epistemological jurisprudential question about what counts as law for purposes of encoding it for different instrumental purposes, right? So the way you've carried, right, so I totally understand the point that tax lawyers and tax clients need answers in a way that oftentimes you can be more, in some sections of the law, clients and lawyers can be more kind of pragmatic and intuition driven. But what I'm hearing between you and Phil, oftentimes the guidance from the IRS is right because it's final. It's not final because it's right? Exactly. So in that respect, it's not, I don't think it's categorically different than a lot of other areas of the law where there's sort of judgments built into some edge questions. The area of law that I've always thought, when I talk with students sometimes about who are, as you know, students are exposed to the law, they're exposed to legal systems, different parts of the law, and they come away frustrated and puzzled by inconsistencies and contradictions and the extent to which judgment informs a lot of how outcomes are determined. And I say, the example I give from my experience is the one body of law that is actually as internally consistent and clear and outcome determinative as any body I've ever encountered is Article 9 of the UCC, secured lending. There's a little bit of a gap at the edge of the intersection of Article 9 and patent law and copyright law. That's a little bit of a weird territory that no one ever really likes to talk about. But as long as you're talking about secured lending for material assets, physical assets, it doesn't have a lot of space for interpretation and judgment. It's sort of designed in a comprehensive way. So one comment here is, I don't know if you've thought about commercial law as a possible next frontier for this. I think it'd be a really interesting test of your premises that, could you take a body of code that is more internally coherent, I think, than the complexity of the tax code, and does Article 9 work in your world? The other thing I just wanted to flag, it's not really, it's sort of beyond the scope of what you're trying to do, but the very end of your talk, you talked about the uses of your project by the government, by the IRS, sort of in an open source, you use that phrase, in an open source code and in an open source community, right, related but different, as kind of a preemptive check on abuse of the tax system. And I wondered if you'd given any thought to sort of what that would look like or what that would entail. Because successful open source projects, whether in the computing world or in the kind of Wikipedian world, rely on pretty robust senses of community. It's not just making the code technically accessible. There's a lot of social life building that has to go with that. And so this is an area I don't know, but I wonder if you foresee either inside the IRS or in IRS in partnership with volunteers or civil society groups or so forth, picking this up and moving it, practically speaking, in the direction that you imagine.
Thank you so much for that. I think it's such a great point. I think all I'm going to say about it is I love that point. Building that community is something that absolutely would be critical for making this work. Sort of for the short term, that we've had to make some decisions there's been some sort of potential for this to be considered to be used by certain governments and so forth. And there's really a commitment, especially, Denis is really the one leading this commitment, but I think it's a commitment of the whole team that's great. And it's not going to go over to the government to be used and changed and without any government or any industry to be sort of used and changed for their use only. And I think that's sort of the initial commitment. And then the question of how to really build it up and have that community that really makes open source stuff work is just it's a great question. And it's something that that we haven't really focused on, but I thank you so much for that comment.
Yeah, well, that's the work that I do. So
that's great.
The overlap, super interesting. Jason, did you want to follow up, or was that a leftover hand from before?
On the idea of community, myself and the executive director of Legal Hackers, Jameson Dempsey, who was also at Codex at Stanford for a while as a resident. The two of us recently set up a website at talk.rulesascode.com. I'll put the link in the chat, and it's basically just a forum/mailing list, and we're trying to invite programmers and lawyers and technologists and public servants and anyone else who might be interested in this kind of thing to join in and kind of use that as a community sharing zone. So we'd be more than delighted to have all of the people in this call sign up.
Awesome. And I'm pretty sure I had talked with him when he was at Stanford about our Knowledge Commons knowledge sharing work that we're doing on my end of things. So there's a nice interweaving of themes. It's 4 o'clock on the dot. So I want to respect everybody's time and thank Sarah profusely for a really stimulating and engaging talk. So fantastic, super grateful to you.
Thank you so much for organizing this. And thank you to everyone for coming. This has just been a really, this is definitely an afternoon I'm going to remember for sure. This has been pretty great. So thank you so much.
Well, it's really a spectacular group of people gathered together. Thank you so much. Robbie, I think we can call the recording to a halt at this point.
Thank you.
We'll put it up on YouTube in due course. Thank you all for coming, and we'll have opportunities to engage going forward. So
thank you so much.